Circular motion is simply the physics of things moving in circles. This happens all the time. For example, you are moving in a circle around the Earth as it rotates about its axis. If you are on the equator, you would be moving through a larger circle per day than if you were in London, which is much further north. However, both of these places would have the same angular displacement at any point in the day. The angular displacement is measured in radians rather than degrees because it makes calculations much more straightforward. For example, the distance you move along the circle is given by the formula S equals r theta, where S is the arc length in meters, r is the radius of the circle in meters, and theta is the angular displacement in radians. There are 2 pi radians in a circle, which means that 2 pi equals 360 degrees, and using this fact we can convert between degrees and radians. For example, an aeroplane performing a loop-de-loop of radius 60 meters turns through 135 degrees. To calculate the distance the plane has moved, we have to first convert the degrees into radians. This is done by dividing 2 pi by 360 degrees to get the radians for 1 degree, and multiplying it by 135, which gives us 3/4 pi or 2.36 radians. This can then be used to work out the distance the plane has travelled as being 141 meters. When an object undergoes circular motion, the object will move at a constant speed but changing velocity. The velocity is changing because the direction is constantly changing, and the velocity is both speed and direction. This means that there is an acceleration, called the centripetal acceleration. The formula for this is a equals v squared over r, where v is the velocity and r is the radius. Another relationship in circular motion is omega equals v over r, where omega is the angular speed, which is a measure of how many radians are being turned through per second, and is measured in radians per second. Another formula for omega is 2 pi over t, where t is the time period for one complete rotation measured in seconds. A centripetal force must be occurring here in order to produce this acceleration. The formula for centripetal force is F equals mv squared over r, where m is the mass of the body undergoing circular motion, v is the velocity, and r is the radius of the circle. For example, another aircraft display team perform a horizontal circle of radius 350 meters travelling at 100 meters per second. From this we can work out the angular speed as being 0.286 radians per second. If the mass of the pilot was 75 kilograms, then we could work out the centripetal force acting on the pilot as being 2,140 newtons. It's important to determine which forces are directed towards and away from the centre of the circle, in order to work out the resultant force, which is equal to the centripetal force. For example, going back to the loop-de-loop performed by the aircraft, there are 2 points in the stunt that are of interest, at the top and at the bottom of the circle. At the top, the normal reaction force acting on the pilot from his seat and his weight are both acting downwards, towards the centre of the circle. At the bottom of the circle, the normal reaction force acts up towards the centre of the circle, and the weight acts down as always. Given that the pilot had a mass of 80 kilograms and the plane was travelling at 100 meters per second, we can work out the normal reaction force acting on the pilot at the bottom of the circle to be 14,100 newtons. And at the top, the normal reaction force as 12,500 newtons, which is a very strong force. Thanks for watching. Make sure to hit the like button if you liked the video, and if you want to see some more, you can subscribe.